Hello people, welcome to my video series on object-oriented programming. I'm actually away from my recording equipment right now, so I apologize for the audio quality, but I wanted to make a video anyway, so let's get down to it. In this part one, I'm going to cover the definition of object-oriented programming as well as some of the problems you might encounter. So let's get started with object orientation. Object orientation, the main idea behind it is encapsulation. So in this diagram here, we have a class called dog, and it has certain state assigned to it. So the dog has a name, it has a certain amount of happiness and hunger. It also has behavior bundled into the object called speak, eat, and fetch. And that is essentially the main idea behind object orientation, bundling state and behavior together into a single object. And this allows us to easily create many objects and organize them together, a very popular way to deal with games. And also in enterprise software development, object orientation became popular in the 90s and is still a staple of development today. Object orientation allows inheritance and polymorphism. So we have two classes here, a dog and cat, and you can see that they share a lot of behavior as well as state between them. Right? They both have happiness, they both have hunger, they both can eat and speak, and they just have certain behaviors which are a little bit different. Inheritance is where we can we can create a hierarchy of classes. So we can take a look at that. If we create a class called animal, which has many of these things like name, happiness, and hunger, and eat and speak, then we can just create dog and cat classes and not have to write the same code over and over again. Or we can overload certain functions like eat or speak and have custom methods for our classes. So that allows us to have a lot of reuse of our code. Polymorphism, I won't go into detail here, but polymorphism has to deal with, it allows us to do things like creating a list of animals. And suppose we wanted the animals to all use their own speak function or method. We could iterate through our list of animals, and depending on whether it's a dog or a cat, the compiler will be able to figure out which method to call, whether it should be the dog speak method or the cat's speak method based on the inheritance of the superclass. And there are whole videos and materials talking about polymorphism, but that is essentially the idea. So some of the benefits of object-oriented programming is that it is very intuitive. If you look around the world, there are dogs and cats, and toasters and ovens, and we as humans see those things as objects, and they have state and behavior. So if we have a toaster, it has a toasting function or a toasting method, and it has internal state where it is in the process of toasting or it's not in the process of toasting. If we call its toast method, it actually changes its state into the toast state and turns on a timer, and the timer will go off and it will stop toasting. Same other kinds of things. If the dog gets hungry, it will start to eat. And so object-oriented design allows us to model our programs in the same way that we model the external world in our minds. Another benefit to object-oriented programming is it creates an easy way to group functionality together. Programs tend to get large over time, and it sometimes is difficult to group things together in a logical manner so that people can find where things are. And object-oriented programming kind of does this for us it provides a framework for us to do this very easily. So all the methods having to deal with dogs go in the dog class. All the methods having to deal with cats go in the cat class. And so we can organize our code very easily and logically, and someone who's new to our code base can come in and pretty much understand things from the get-go because things are organized in a logical fashion. There's lots of history behind object-oriented design. In fact, it was invented by Alan Kay. And what we know as object-oriented design right now is actually very different from how Alan Kay envisioned it. But because of the success of these misinterpretations of object-oriented design by C++ and Java, when we refer to object-oriented design, we refer to the common design and not Alan Kay's definition. So anyway, object orientation is widely known, and there are many books and learning materials teaching people how to do it. And that's a huge benefit because you can always go around and ask another programmer or read a book on how to do object-oriented design. It also means that as far as game development and enterprise software development, that there are likely to be standard object-oriented design methods out there, and if you learn them, you'll be able to take them from job to job and do well. However, that doesn't mean object-oriented design is a perfect way to develop software. There are problems associated with any way that you put a program together. And so let's just take a look at a few of them. One is called the diamond problem. And I'm just going to pull up the Wikipedia page here. And this diagram is a perfect illustration. The diamond problem is where you have a class that inherits from two other classes. And those two classes have the same base class. And so suppose B and C have the same method right in here. So say it was speak or something like that. And D does not override this speak method. Well, how do we know which method to call if speak is called on D, right? There's no way a priori to know. And different languages, as you can see in this article, different languages have different ways of dealing with this problem. But it's a problem, nevertheless, that needs to be solved by either your programming language or the standard protocol from when you're programming. Another problem with object-oriented design is the deliberate creation of state. When there is a bug in a program, you have to be able to reproduce it. And that usually means reproducing the state of a program. Now, if a program has thousands of objects in it, and there happens to be a certain configuration which causes a bug, it can be difficult or nearly impossible to recreate that state in order to figure out what's going on with the bug. And creation of state is kind of the heart of object-oriented design, because remember, an object is a bundle of state and behavior. And so if you're going to have an object-oriented software, it's going to have state spread all over the system. And because of this kind of problem, there has actually been a reaction against object-oriented design by an opposite design method called functional programming. And functional programming tries to avoid state at any cost. It also tries to avoid side effect. But functional programming is a topic for an entirely different video. So anyway, the deliberate creation of state, which is possibly unnecessary, can make a program far more complicated and difficult to debug than it needs to be. Finally, for the third problem that I will talk about here, this is not an exhaustive list, but the third problem I will talk about is method inclusion. When you're creating an object, you have to decide what methods are going to be inside it or not. So for example, if you create a class called graph, there are obviously going to be some methods that should definitely be included, like inserting a node or deleting an edge. But there are other kinds of methods where it is not quite so clear. Should we include a method that returns the shortest path between two nodes in the graph? And if we include that, should we have a method that returns the longest path between two nodes? Should we include methods for betweenness centrality or any of the other centrality methods for graphs? This becomes very difficult because if we really want to adhere to object-oriented programming, then we should have an exhaustive list. But exhaustive lists of methods could run into the hundreds or even thousands, depending on how your object is designed. And normally what happens in these cases is you try to limit your methods to just a few core methods that you need for your object, and then everything else is external. The problem that this creates is that all those external methods are kind of second class. They're not really part of your class that you created for your object, and they're just external. And now you have to worry about organizing them and coordinating them. And if you have a team or even groups of teams, if you have a large software development organization, then you're going to have politics become involved, because different groups and different individuals are going to have different ideas about what should and shouldn't be included as a method in the object. So those are just some of the problems. In the next, and that's probably good enough for this video, but for the next video we're going to actually look at object-oriented design in a more concrete manner. We're going to look at a C++ program implemented in an object-oriented way. So thank you for watching, guys. Till next time.